Hey everyone, let's talk about numbers. We use them every single day, but have you ever stopped to think about how they're all organized? It can seem like a bit of a chaotic mess, but there's actually a really beautiful and simple system hiding in plain sight. So today, we're going to pull back the curtain and make sense of it all.
So let me start by asking you this. Are all numbers created equal? It seems like a simple question, but the answer is a big, fat no. It's actually a lot like biology. Numbers belong to different families, and each family has its own special rules and characteristics. And once you get to know those families, the whole world of math just starts to click.
I mean, look at this. At first glance, it's just a random bunch of symbols, right? You've got negative numbers, you've got fractions, you have decimals that just seem to go on forever. It looks totally random. But I promise you, by the time we're done here, you'll see exactly how each and every one of these fits into a perfect logical system.
So, where do we even begin to sort this out? Well, we're going to start right at the beginning, with the very first numbers that you or I or any human ever learned.
And here they are, the natural numbers. You can also call them the counting numbers, and that's exactly what they are. These are the OG numbers, the ones people invented thousands of years ago to answer the question, how many? How many goats do I have? How many days until the next full moon? It's just 1, 2, 3, 4, and so on. Simple, positive, intuitive.
Now, here's where we make our first big leap forward, with one tiny but brilliant addition, the number 0. It seems obvious to us today, but the concept of 0 was a total game changer in history. When you take those natural numbers and you just add 0 to the group, you create a brand new family, the whole numbers. And suddenly, you have a way to talk about having nothing, which is a really powerful idea.
So if you picture this on a number line, it looks kind of like a one-way street. It has a definite starting point, bam, right at 0, and then it just shoots off to the right forever and ever into the positive. Nice and simple. But what about the other direction?
This is where our number line gets a massive upgrade. We're about to punch right through that 0 barrier and discover a whole new universe of numbers on the other side.
And say hello to the integers. This group includes all of those whole numbers we just met, but now, for every positive number, we also have its negative twin. And we need these guys all the time to describe the real world, right? Think about it. A temperature that's below freezing, a bank account that's a little overdrawn, or being hundreds of feet below sea level. You have to have negative numbers to talk about that stuff.
And you can see it right here. Our number line isn't a one-way street anymore. Now, it's a true line. It's an infinite highway stretching out in both directions, perfectly balanced with 0 sitting right in the middle.
Okay, so our number line is looking a lot more complete. We've got all the whole numbers signposts marked out. But what about all that empty space in between the signposts? I mean, where does a number like 1.5 live? Or 2/3?
This brings us to our next and much bigger family, the rational numbers. The secret to understanding them is right there in the name, ratio. If you can write a number as a ratio of two integers, in other words, a simple fraction, then it's a rational number. That's the only rule.
And this family is huge. It includes all the obvious fractions, like 3/4. But here's the cool part. It also includes all the integers we just talked about. Why? Because you can write any integer, like the number 8, as a fraction. Just stick it over 1, 8 over 1. And it also covers decimals that stop, like 0.75, or decimals that go on forever, but in a repeating pattern, like 0.333 and so on.
Okay, so we've now filled in a ton of the gaps on our number line. It's getting pretty crowded in there, isn't it? You might even think we've finally covered every single possible point. But there's another group lurking out there, a much stranger, more mysterious family of numbers that just refuses to play by the fraction rule. So here it is, the fundamental difference. Rational numbers are predictable. They're tame. You can lock them down into a nice, neat fraction. Their decimal version either stops dead or it gets stuck in a predictable repeating loop. Irrationals, they do neither. They break both of those rules. They're the rebels.
And here's what that means. The decimal for an irrational number is pure, beautiful chaos. It goes on forever and it never settles into a repeating pattern. It's just an endless, unique string of digits. You could literally spend an infinite amount of time writing it down and you would never ever reach the end or see it repeat.
And the biggest celebrity in the irrational numbers club is, of course, pi. We all learned about it in school for finding the circumference of a circle. But its true identity is that its decimal, 3.14159 and so on,
just keeps on going for trillions of digits with absolutely no discernible pattern.
Another really famous one is the square root of 2. And this isn't just some abstract concept, it's a real length. If you have a perfect square that's 1 foot by 1 foot, the length of the diagonal is exactly the square root of 2. It physically exists, but you can never, ever write it down as a simple fraction. Its decimal just keeps going wild and free.
All right, so we've met all the individual families now. We have the naturals, the wholes, the integers, the rationals, and the irrationals. So now it's time to put all of these pieces together and see the complete family tree of numbers.
The best way to think about it is like a set of those Russian nesting dolls. You start with the very smallest doll in the center, the natural numbers. You click that inside the next biggest one by adding 0, which gives you the whole numbers. Then you snap that inside an even bigger one by adding the negatives. Now you've got the integers. And finally, you place that entire collection inside the biggest doll yet by adding all the fractions. And that whole giant nested set is the rational numbers.
So what happens when you take that massive, orderly group of rational numbers and you combine it with that other, separate, chaotic group of irrational numbers? Well, you finally have everything, the whole shebang. This giant combination is the set of real numbers, and together they account for every single possible point on the number line. There are absolutely no gaps left.
And here is the complete map of that number universe. At the very top, you have the real numbers, and they are split into 2 completely different teams that never mix. On one side, you have Team Rational, all orderly and predictable, with all those other families nested neatly inside. And on the other side, all by themselves, you have the wild, unpredictable irrationals. They're different, but you need both teams to make up the entire number line.
So let's go all the way back to that chaotic jumble from the beginning. See, it's not chaos at all now. We know exactly where each one belongs. 8 is a natural number, which also makes it a whole, an integer, and a rational. -5 is an integer, which also makes it irrational. 3/4 is clearly irrational, and pi and the square root of 2 are rockstar irrationals. See, everything has a home. So we've classified everything, which is fantastic. We've brought order to the chaos. But I want to leave you with one final, deeper question to chew on. You know, it's one thing for me to sit here and just tell you that the square root of 2 is irrational. But have you ever wondered how we actually know that? How can we be so absolutely certain that out of the infinite number of integers in the universe, there aren't 2 of them that can form a fraction that perfectly equals it? Now that is a pretty amazing story for another time. Thanks for watching.